So what affects the margin of error? Well, whether we're working with means and standard deviations. Okay, so what do? We do z star times the standard deviation for the population divided by the square root of n. Or if we're working with the t-distribution, t star with, what is it, alpha divided by 2 degrees of freedom, and then the sample standard deviation by the square root of n. Or whether we're working with proportions, where we have p hat plus or minus z star times the standard deviation for the proportions is, what is that? That's, what is that? P hat times 1 minus p hat all over n. Okay, what makes the confidence interval narrower? Well, if I have, I don't know, let's keep this easy. We'll just worry about z-score, since I know that doesn't change based on the sample size. So let's say I've got to do a 95% confidence interval, and I have a standard deviation of, I don't, let's keep it easy. Let's keep it I have a standard deviation of 1. And I've got a sample size of let's take something, we take the square root of 25, or then 100 even. Okay, suppose we get these two samples. What's going to change about this? Now remember, this part's the margin of error. So if I have, and for a z-score, 95% level confidence has a z-score of 1.96, and I've got a standard deviation of 1, I said. I'm going to put that over the square root of 25 for the smaller sample. So what's that margin of error? So that's 1.96 times 1/5, or that divided by 5. And we could calculate that as something less than 1. It's probably something around 0.4, right? Here, we'll say it's about 0.4. And then if I have a sample size of 100, 1.96 times 1 over the square root of 100, well, that's the same thing as 1.96 divided by 10, which is 0.196. So a larger sample size shrank the margin of error. And that's one way to, if your margin of error is too big, go out and pay for a bigger sample. Companies have to do that sometimes. The other way you can either increase or decrease your margin of error is by talking about the level of confidence. We'll go with the sample size 100 for this because, for the t-distribution, you need a sample bigger than 25 or bigger than 30. So, but of course, with z-distribution, it doesn't matter as long as you get that normal curve, normal distribution, and you know your standard population standard deviation. Gosh, I sound like a salesman. So, if I want to increase, if I want to make my level of confidence higher, what if I go to a 99% level of confidence? And I think the z-score for the table for that one is 2.575. If I have a sample size of 100, we're going to do 1 because that's my standard deviation I made up over 100. So won't that be 2.575 over 10, which is 0.2575? And with a 95% level of confidence, we had 1.196. So do you see how increasing your level of confidence made the margin of error bigger? Remember, that's what we add and subtract to the point estimate, the sample mean, right? That's the point estimate. That's the point estimate. Okay, so if you increase your level of confidence and keep your sample size the same, the margin of error gets bigger. If you decrease your level of confidence and keep the sample size the same, you shrink your margin of error. If you increase your sample size, the margin of error gets, but keep your level of confidence constant, your margin of error gets skinnier. Okay? It all depends on the z-score you're using, or t-score, and your sample size. Okay, hopefully that answers your question and understand what's happening there.